Okay, so good day, everyone. I am Jared C, and today we're going to talk about object oriented programming and the basic concepts. Okay, so we have an introduction. Okay, these are the agenda pala. Okay. Um, we have the introduction. What is object oriented programming in general? We have classes and objects, the most basic components of OOP, and the difference between them. Principles, which are the four important concepts of OOP. And lastly, of course, conclusion, so we can recap what we have learned from these lecture. Okay. First one is the introduction. What is OOP? As you can see, object-oriented programming revolves around objects. Okay, so what does that mean? We break down real-world problems or any other problems to different objects that interact with each other. Okay, so it's more focused on data rather than functions and logic, as similar to C. Okay, so this might seem a little confusing. I mean, it's so high level. What does that even mean? Okay. Let's look at some examples first and start to identify the different objects and the interactions that happen between them. So in the first statement, a boy feeds his dog. So what are the objects that interact in these statements? So it's a boy and the dog. No? And what is their interaction? It's feeding. Okay. Of the boy object feeds the dog object. Okay. How about the next statement? Might seem a bit more subtle, but the two objects are the address book and the addresses. Okay, those are the two objects. And what's the interaction? The storing. Okay, an address book stores addresses. Okay. The third one's a bit more obvious. So the girl, apple, and the interaction is eats. Okay. And then how about the fourth one? No? So we have three objects. Okay. I mean, in the statement, there's only two, no? Father and son, and then they play. But if you think about it deeply, when you imagine two people playing catch, obviously there must be a ball. Okay, so that's the other object that's implied. Okay, there's a ball, and what do these people do with the ball? They throw it. So that's another implied interaction. Okay, so the ones in red are the objects, and the ones in blue are the interactions. Okay, this one's implied. Next. Okay. So we've identified the objects and their interactions, but how would the code base look like? You're familiar with C, it's all just sequential functions going here and there. But in object-oriented, what would the code look like? So we'll focus on the address book and the addresses. Okay, it's more simple. So here's how it would look like. We have a class called address. Okay, it's in its own file, so it's address.java. And we have an address book stored in addressbook.java. Okay. So we have these variables. Later we'll explain what they are. Okay. So name, house, number, street, city, country. Then another method. Then an address book, which contains an array. So it's an array list, I know, but let's see it as an array for now. And then it has a function called store, which adds an address to the array. A remove, which removes an address from the array, and then display addresses, which prints all the addresses inside the array. Okay. Okay, so next. We already declared the objects here. Okay, the classes rather. So we'll see the difference later. So we have their own self-contained file, so it improves modularity, which helps in debugging and tracing. And then lastly, we have the driver class. Okay, this is usually the main program. So in C, we also have the main. So here we also have main, and this is where they interact. So a while ago, we made different classes, files. We created the objects. Okay, and then here is where they interact in the main sequence. Okay, this is where the interaction happens between them. So we created two addresses here. Okay. Then we created an address book in line 3. Then we printed, we made a printing addresses, and then we stored the two addresses inside the book, and then we displayed the addresses. Okay, so that's why there's Jared here and C here, okay, from the two addresses. Then we remove one address 1 being this one. Then we print after removing addresses, and then this one is the display address, the output display address. Makes sense, huh? Works. Okay, so that's just a glimpse of what they look like. So based from these classes, is there a familiar concept in C that you remember? Specifically this one, what can you see? Structures. Okay, remember the struct types or record types in C? We have a name for the type, and then a bunch of containers, a bunch of variables, okay, which act as containers for the whole structure. So the purpose of this is to store, no? And it's no different from a class. Okay, a class is made to store data. Okay, so what's the difference between that and a class? Okay, so the difference is that there are functions declared inside, as you can see here. Okay. So I think that's the only difference. Okay, so classes are just structs on steroid, which also contain functions. So let's make a quick comparison on procedural versus object-oriented. So in procedural, we have C, which you studied in Prog 1 and Prog 2. So an object-oriented is for Prog 3, and we're going to learn Java. So in procedural, as I'm sure you've done in your Prog 1 and Prog 2, is you first identify the steps for solving the problem. Those tiny, really step-by-step process in solving the problem. Okay? And then it executes in sequential order, definitely. I mean, if there are functions, it goes to the function, and then back to the line where the function was called. Simple, easy to trace. Then it's organized around data and, most of all, logic, the flow of your program. Okay. Meanwhile, in object-oriented, the first step is to identify the entities and the problems. Just like what we did in the other slide. No? From the statement, we identified what objects interact and what that interaction is between those objects. So that's the first step. And then the second is to model each identity as an object and make them interact like they would in the real world. In the driver, the main program, that's what we did. Okay? The book stores the addresses. Okay? So that's how they interact. Then it's more organized around data and objects. Okay. So now that we're clear on that, the introduction is done, and let's start with differentiating classes and objects. And both of these are the main components of OOP. So another comparison table. Okay. So at the left, we have objects or instances. And then at the right, we have classes. Okay. So for the first bullet point, it's an instance of a class. An object is an instance of a class. Meanwhile, a class is a blueprint or a template from which objects are created. Okay, it's a group of similar objects. On the left side, we have a real-world entity such as a boy, pencil, or laptop. Okay, so to make this clear, okay, as mentioned, a class is a group of similar objects. A template, okay, for example, a student. A typical student has an ID number, a name, an age, a section, no? Those are templates for students, a typical student. And then we have an instance of a student, which is, for example, me. I'm a student, so I have ID number 119. I'm Jared. I'm age 20. Okay, so those are states. It's a particular person na, an instance, diba? Specific instance na. But a class is just a general thing. Okay, let me give another example. We have, for example, class cat. No? There are many cats in the world, but they have claws, they have teeth, they have paws, fur, tail, and then, but we're not really pertaining to any specific living cat. No? But an object of a cat, a specific instance of a cat is sitting right here beside me. Okay, so that's an instance. So it's a physical entity, and class is more of a logical entity. We just group things. We can't really point at a class. Okay? Meanwhile, we can point to an instance. Okay, and an object can be created many times from a class, okay? But a class is only declared once. Okay? I hope it's clear because this is an important concept. Okay. Okay, so here we can see that we only declared one address class. Okay, one class here containing whatever these are. And then in the main program, the driver, we declared two addresses, namely add1 and add2, but they are of the same class, one single class, but different instances. Okay, diba? Okay, so next, we have a parts of a class. Okay, so there are three. First is the fields, or the states, or the data they hold. Next is the methods, which define the behavior of a class, and then a constructor. Okay, so we'll see what they are. Okay, so first one is the fields, states, or data. Okay, so it indicates what can be stored in objects of that specific class. Okay, in this example, we have a class address. Okay, if an object were to be initialized of class address, what should it contain? What data should it contain? Okay, so we have a house number. Okay, makes sense. A street, a city, and a country. Okay, these are all inside an address. They are stored inside an address, which makes sense. Okay, and then these are also values that are accessible within the class. So we saw a while ago that there are functions declared inside the class, so they can access the variables here, declared here. Okay. Next are the methods and behavior. Okay. So it indicates what objects of that class can do. For example, in our address book, in our class address book, we have a function, a method, okay, called store, which receives an address and then stores it, adds it inside our array. We have a remove, which removes it from the array. We have display addresses, which prints all the addresses inside our array. Okay. So methods indicate what a class can do and what can be done unto the class. Okay. So we know that an address book can store, an address book can remove, an address book can display the addresses inside because we declared it. Okay. And basically, methods are just functions that have access to the fields of the class. Okay. So as you notice, addresses is a field, and then all these functions, all these methods have access to it. Okay. So it's like a global variable within the scope of the class. Okay. And lastly, we have a constructor. Okay. So what's a constructor? It defines how objects are to be created from the class. Okay. So we can see here, public address. So notice that the constructor has also the same name as the class. So if the class is address book, the constructor should also have the name address book. Okay. So it receives these parameters, a name, house number, street, city, country, and then it initializes the fields inside the class. Okay, so if you're wondering what this keyword means, it just pertains to the class itself. Okay, so the object itself rather. So this dot name is equals to the name passed. Because if there's no this, we'll just assign the parameter to itself, which doesn't make sense, diba? So due to the namespace limitations, you have to pertain. How do we pertain to the name of the class? Okay, we use the this keyword. Okay. So to clarify, let's see this. Okay, so we define a constructor here, no? That's why when we created an address here, we just pass the name, the house number, street, Paris, France. No? Okay, so they are received here and assigned. So the name is assigned to this dot name. So this is this dot name, this dot house number, this dot street number, and you get the point. Okay? So that's what a constructor is for. It tells the program how an object is to be created given the set of parameters. Okay.